Today, I don't think I'm gonna be there. We can work together and stuff. All right. We're in Precalculus lesson 3-13, continuous compound interest. Today's date has lots of 2s and 3s in it. It's the 23rd of March in 2023. Look at that.
2, 3, 3, 2, 3.
Right? And yeah, just lots of 2s. So, I want to title this section the speed limit of interest. I will be honest with you guys, I'm like at a 4 out of 5 for my understanding of today's lesson, so bear with me. I am hoping to get myself to a 5 out of 5 by the end of today. I know the derivation of everything, which is the important test.
See, we should have done this in consider math, Me and Chloe would have had like already prior knowledge.
Right. So I want to talk about a bank that is, we need to come up with a name for this bank. It's like a really, really good bank. Like, what's the best bank in the world? What should we name it? Like, it's a non-evil entity that is maybe a little bit stupid. What should we call it?
Timothy's Bank.
Timothy's Bank. I want to talk about Timothy's Bank. I cannot spell. Timothy probably spell like that, right?
Timothy. With the U, Timothy.
What's the U go?
Timothy.
So this is Timothy's Bank. Timothy's Bank is kind of cool, and by kind of cool I mean magically amazing. This would never exist in the real world. But Timothy's Bank will give you 100% interest at the end of the year. At end of the year. That is unheard of because do you know how much percent interest you typically get at a bank?
Like 0.01 or 0.2.
Yeah, it's usually 0.0, I think mine is 8%.
Yeah, I thought the average was like 0.9, I remember.
It's really low, but so that's why this is magical. This is unheard of. Like if anyone did this, they would lose so much money because usually the riskiest place is the best return. The riskiest place right now is the stock market, and the average return on the stock market, like the 10-year average, is about 10%. So if you're giving 100%, you're losing 90% every year. Don't offer this percent. Anyway, so you have 100% interest at the end of the year, which is a fancy way of saying you double your money at the end of the year. So I want to go ahead and outline a few different timelines. In timeline number 1, this is scenario number 1. You put, let's go ahead and put, I want to do there's too many hundreds if I make it. I want to deposit $100. I want to put $100 in the bank. And then at the very end of the bank, or at the end of the year, I'm going to go all the way over here. This is in 1 year. How much money do I have? That's double the 100.
Oh, my fault. 200, my fault.
Yeah, because again, 100%
I
is
multiplied by 10.
Double
I multiplied by 10.
your money. So in 1 year, yes, we have $200. So we went up by 100%, which makes sense because that's what was promised. It's 100%. That will change because we're going to try to make this as smart as possible. We were trying to get as much money from Timothy as possible. Watch what happens in scenario 2. In scenario 2, I'm going to take the same $100. The start is always going to be $100. The only thing that's going to change is the amount of time that I want my money back. So this is 1 year, by the way, is what's known as compounding annually. And is it biannually? It compounds every half year? I don't think it is. Biannually means every 2 years. I don't know what it's called, but I'm going to compound semi.
No, but
so many
that's,
different words.
yeah.
I'm going to go ahead and do this. I'm going to do 6 months. And then I'm going to go another 6 months. And on first inspection, you say, okay, you should probably end with $200.
What does that mean?
Right? And the answer is no, it isn't $200 anymore. It changes because you actually, the interest that you get here accrues interest. It accrues, a fancy way of saying it, gets more things. So it accrues interest. So let's look. If I have half the amount of time, then I should go by half the amount of interest. So this 1 year was 100% interest. I'll put that up here. This 1 year was 100% interest. This 6 months must be half of that. 50% interest. This must be 50% interest. So if you don't have a calculator already, either use a Desmos calculator on your computers or grab a calculator from my wall. You all will need to help me with this.
So do you take 50% of 100, but then you take 50% of 150?
Yes, yeah, she's the step ahead of us, that's okay. So, by the way, if there's a 50% increase, do you guys know the shortcut for that? This is super important to know here. I'm gonna skip down here and talk about shortcuts because you need, in fact, I'm gonna move this all down to talk about shortcuts. Okay, whatever, I'm gonna do it down here. I'm gonna talk about percent increase, increase / decrease shortcut. If you have a 25% increase, that is the same thing as multiplying by 1.25. Why? Because a 25% increase, here's the long process, and that will eventually show why the shortcut works. The long process here is you say, okay, start with, it doesn't matter what amount of money. 100 is a nice number because it has 2 zeros and it gets rid of decimal places at the very end, so that's why I like it. Let's go ahead and say you start with $100. If I have a 25% increase, I'm gonna do $100 and then I'm gonna add on 25% of 100. That's what a 25% increase means. It's 100 plus 25% of the original deposit. So here we go. We can say this is now $100 plus. How do I do 25% of 100? Well, you convert it from a percent into a fraction or decimal. But I prefer decimals because if I have the number like 29%, 29% as a fraction, that's just 29 over 100, and it's not as useful. I have to do 2 operations: multiply by 29, then divide by 100. Or I could change this into just 0.29, and then I have 1 operation instead of 2 operations, which is just to multiply by 0.29. So I prefer converting to decimals because there's only 1 operation. If you're okay with saving work, let's all convert to decimals. We're all nodding your heads yes, and let's assume Alden is as well. So what I'm going to do here is I'm going to say this is going to be not 25%, but the decimal 0.25. So we'll do 0.25 times 100. And this is where you guys have your calculators. You can do this in your heads. What is 0.25 of 100? 25. It's exactly 25. So this is now $100. $100 plus that $25, and you get your resultant $125. Cool. Here's what we were really doing though. This is the shortcut. I'm going to show it right over here. What I could have done is factored out something, because this is saying what is 100 plus 25% times 100. Do you see something that's the same twice? Yeah, that number 100 can be factored out. I can say that this is really 100 factored out. So that means I'm dividing each of these by 100, dividing each of these by 100. When I divide 100 by 100, I'm left with 1. And when I'm dividing by 100 over here, you just kind of cross, you're left with 25%, yeah, plus 25%. And what did we do with our percentage? We converted it into a decimal. So this was really starting amount times 1 plus 0.25. And you will note that 1 plus 0.25. So there's the shortcut in a nutshell. I will write out the formula all in red so that we can remember. I think it's always going to be start times 1. You can either do plus or you can do minus. Plus will go up, minus will go down. So for example, if it's a 25% decrease, you do 1 minus 0.25. If it's a 25% increase, then you do 1 plus 0.25.
So I can't remember seeing this, something like this.
Yeah, this is exact same formula. Percent to decimal goes here. And there it is. I guess there's a multiplication problem out front, which you always assume. So it's the start times, and then that's the key piece right here, 1 plus or minus the percent to a decimal. So in this case, 25% increase, you change it to decimal, point, it's 0.25, it's increased, so you add it, 0.25 plus 1, 1.25. Over and over again. We're gonna use this trick. You guys are about to use this trick. So it's not just, oh, that's a cool trick. It's here. This is a tool, and let's see how well you can use that tool over and over and over and over again. Ready, set. All right. I said increased by 50%. What am I multiplying by?
0.5. No.
Are you doing like 100 and then the 1 plus 0.5?
1. Yeah. So you're starting. I'll write it down here. We're starting with $100, and we're going to multiply by 1. It's an increase, not plus, or sorry, not minus, but a plus, and then that number 50% as a decimal. 0.5, which is 1.5. You said 0.5, right? Yes. Yeah. So we're going to do 100 times 1.5. Calculators, go. An easy calculation. You can do it with your heads. You will eventually need your calculators. What is 100 times 1.5?
115.
It is indeed $150. This is where you probably now need a calculator. Again, when it increased by 50%, which I already told you is the same thing as multiplying by 1.5. So again, you're going to say multiply by 1.5, and we get.
I'm sorry, 225.
Okay.
Or 150 times.
So let's go ahead and stand back. I want you to start seeing the bigger picture right now. And then we're going to keep doing more of these and more of these until you get lots of practice on how to increase by certain percentages really quickly. And so you can start seeing this weird pattern. This is the fun thing about math is I show you a cool problem and you look for that pattern and you ask, why? Why is there that pattern? So we got more money. That's the first thing that I noticed. Hooray, we're $25 richer by just doing something as simple as saying, hey, instead of 1 year, I want 2 different 6 months periods. I broke it up into smaller intervals and I got more money. That was the first thing that I wanted you to see. The second thing that I want you to see is why. Can anyone explain why? It's a really hard question. It feels like, wait, if you just broke up the 50% from 100%, like it still kind of adds up to 100%. So what the heck happened here? Where did that extra 25 bucks come from? And yeah, Chloe?
I don't really know how to explain it mathematically, but it's taking 50% of the beginning number, but then you're taking another 50% of the new number instead of just doing 100% originally.
Exactly. No, that's perfect. And I can rephrase it in a slightly better terminology. We got a little bit of extra money here. We went from 100 to 150. Over here, the interest is only applying to the $100. Interest 100, interest 100, interest on the 100, interest on the 100, interest on the 100. That $100 stays constant. Now we have a little bit more money, which means this 50% interest applies to the money that we just got. The money that we just increased from our interest rate is again getting more interest. The interest is building interest. Interest is a word that you can say like, I made money from the interest. The money that we made on the interest is also getting more interest. This money is increasing exponentially, more or less.
Could you explain to me how did we get 225? Because I was trying to like look at it and figure it out, and I got like 300. So
Yeah, so on your calculator, do you have your calculator ready?
yeah, I have my calculator.
Go ahead and hide Zoom. I'm just going to do this verbally verbal instruction. You have $100, so type in $100.
Yeah.
You're now going to multiply that by 1.5.
Yep.
And you should get 150 after 6 months. Now, with that number, 150, again, multiply that by 1.5 because that will be another 50% on the original $150 after the end of the year.
Oh.
So you're multiplying by 1.5 twice.
Okay, now I see, because I thought it was like, yeah, never mind.
Okay, you're good. All right. I want you guys to all make a prediction. What happens if we take that same $100 and we split it up Should we split it up every quarterly? So there's 4 different periods. Should we split it up every month? How much math do we really want to do here? I think we should split it quarterly because there's 4 people currently in class, right? All right, everyone get your calculators ready. This is how we're going to split it up. We're going to do 3 months, 3 months, 3 months, 3 months. We're going to see what happens. So this is 3 months, 3 months, 3 months, and 3 months. Alvin, you ready to start us off?
Yeah.
I'm giving you the harder question, not the procedural question. Back here, we increased by 50%. Now that we're dividing it into 4 different periods, what should our percent increase be now?
25%.
25%, which means, Alden, what am I going to be multiplying by every single step? Not 1.5, but
1.25.
every single time we're going to multiply by 1.25, multiply by 1.25, multiply by 1.25, multiply by 1.25. All right, Alden, you go first. What's the amount after the first 1.25 increase? What's 100 times 1.25, Alden?
It is 125.
125. Diego, another 25% increase leaves you with what? And everyone is doing this on your calculator with us. You're not just taking Diego's number, you're doing this with Diego.
187.
187.5. Emma, 25%
How
increase.
did you get the 187?
Oh, I multiplied it by,
The 125 times 1.25?
yes.
You get a different answer, but
Yeah, I did 125 times 1.25 and I got 156.
Oh, 25. Whoopsies. Oh, look, I put it by. My bad. I got 156.
156.25. Thanks for checking that, Chloe. Emma, 3125, so I'm gonna round it to 31 cents. And Chloe, at the very end, what are we left with?
244.14.
And I should have let you guys make a prediction, but the prediction should have been, what do you think will happen? Will we, like, how much will this increase? This one went up by $25. This one did not go up by $25, even though we cut it in half again. You think, oh, I'm gonna go up to maybe $250. Not quite. It went up, but not as much as I was expecting. I was expecting, oh, $25, another $25. It went up by less, but still a lot. Like, I got, what is it?
Does it have to do with the percent of change?
Yes, but it's not as easy as that. So let's go ahead and do one final example where we just kind of jump to the answer. What would happen if we did, I know I said one final example, this is going to be me doing example number 5. You are doing example number 4. What would happen if I did it monthly, which by the way is how banks work, they do it monthly. What if I had the $100 and I increased it monthly? So it's 1 month, 1 month, 1 month. And I do that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. What percent interest should you charge for each of those months?
Is it 8.3?
Yeah, how'd you get that?
Oh, if you divide 100 by 12.
Yep, so 1 over, well, I guess you said, yeah. It's 100 divided by 12%, which is, you said 8.3%, which means I'm multiplying by 1. Oh, careful, that's 83%. I want to say 8.3%. 1.083, right?
Why?
Why?
That's a great question. Let's come and answer that down here. What if I said, I want to increase by 7%. That means I'm going to do multiply by 1 plus 7% as a decimal. Convert 7% to a decimal?
0.07.
No, 0.07. So if I convert 8.3% up here into a decimal, I'm going to have another 0 in front of the, or in between the one
I
and
thought
the
it was
eight.
83.
But why, but for 25%, it's not that.
Exactly, 25%, 25%,
Oh,
Converts
because it's
to
8.3%,
0.25.
it's not 25.
exactly.
Okay.
Good, and I would like you, Chloe, to not round. Anyone that's using your calculators, I do not want you to round. Everyone should be having your calculators open. Make sure that you have 100 divided by 12, which is gonna be 8.3%. Then divide that by 100, which is really meaning you should have done 1 divided by 12 at the very beginning. Everyone should have 0.08333333 repeat, right?
Yes.
Add 1 to that, so now you have the number 1.08333333 repeating. I want you to have the number 1.08333333 repeating exactly on your calculator, stored. I don't want you to round. So again, our steps. Just do 1 divided by 12 was your first step, because that will give you to 0.083.
Yeah.
Now you're going to take that answer, so you can type in A and S if you're doing it on Desmos, and say that answer plus 1. You should now have 1.083333 repeat. Everyone is good?
I didn't do a repeat.
Right.
You have to do it by manually. You have to do those steps. You have to do 1 divided by 12. You can't manually type in repeat.
So just a prediction, can you do 100, like using the formula, do 100 with that, well, it would be 9.3 repeating. Can you put 12 outside of the parentheses to do the repeating?
Yeah. They're already seeing the next step, which is good. That is exactly where we're going. So
That's it.
I'm gonna let you guys see that on your own right now. You need to do this 12 times. So you're gonna take 100 and you're gonna multiply it by 1.083333. That was the first time. Multiply. You're gonna take multiply by 1.083, multiply by 1.083, multiply by 1.083, and you're gonna do that 12 times. There's a shortcut. Look for the shortcut. I think Claire, you found the shortcut. And I need at least 3 out of the 4 of us to have the same answer at the very end to make sure that we got the right answer, and make a prediction as well. I'm gonna guess it's gonna go up to 200 and what? You already have the answer though, right? Yeah. So Diego, you have to do this now.
Can I borrow your charger?
Yeah. Yoink. Yoink. You have to sit by that one somewhere. You can do it on the, it's actually easier to use the calculators on the wall, surprisingly. All right, Chloe, what is the starting number that other people will check?
The what number?
What did you get for your final answer? And then other people will check to see if they get the same answer.
11,200. Is that wrong?
11,200.
Yeah.
Oh, wait, that's why. Hold on 1 second. I just took the answer and plugged it in, I didn't realize. Oh, it's 111.6.
So
Never mind, never mind.
111, so we've gone down.
$1,200?
1,200 is what you're getting?
No,
So
2,200.
now I got 1,311. Think I
These
put-
numbers are all way too big. Here, let me show you how I would do it on.
1,299.
Feels too big. Okay, let me show you my work. All right, you guys ready? Set. I start with 100. I'm gonna just hit enter. I'm just gonna go line by line so you guys can see what's happening on the calculator. Then I'm gonna do the answer. You can just type in A and S, or I'm hitting this button answer to the right of the decimal and to the left of the plus sign. And I'm gonna say times. Oh, I need my X. Hold on. So I need to say that, let's go ahead and say, I'm gonna create a variable X. And I'm gonna say X is exactly equal to 1 divided by 12. And I'm gonna add 1 to that, so plus 1. So now I can just say, I can keep multiplying by X. So if I multiply 100 times X, so I'll say 100X I get my new, so at the end of the first month, you should have $108.33. Everyone get that for your first step.
$108.02.
At the end of the first month, you should have $108.33.
I did not get the reading.
That you messed up already.
How?
Did you do 1 divided by 12 plus 1?
Oh, did you save the number as a variable? Or did you just do the 0.83 and just didn't do the rounded one?
I'm gonna go ahead and do those.
So this number, this x is equal to 1/12 divided by 1. Or 1/12 plus 1. This is the number that we're going to multiply by over and over again. We're going to take a number, multiply by 1.083, multiply by 1.083, multiply by 1.083. That's what I'm setting up, and I set that equal to x, so I wouldn't have to keep typing this in over and over. I can just type in x. On our very first jump, to get from here to here, this first jump, I'm taking 100 and I'm multiplying by 1.083. That's what I just did right here. I took 100 and I multiplied by 1.083 or x.
Oh,
At the end of the first month, I should have $108.33. So right here, I know it's kind of scrunched in here. Let me maybe move you guys over here. At the end of that first month, I have in blue $108.33. And we're gonna do it again. So now I'm gonna say, over on the calculator, I'm gonna say, now, I'm gonna enter, I'm gonna say, now that answer, I'm gonna multiply again by x. And I get a new number, I get 117.36.
I'm trying to figure out what's wrong with the way I'm doing it though.
I'm gonna come to your, I think you're trying to do a shortcutting method. I will derive the shortcutting method after I'm done. Just making sure that we're all understanding that you're just multiplying by that same number over and over again.
By 12 times.
So I'm gonna do it once, twice, and you say, yeah, you have to do 12 times. Answer times x. You get the next number, which is 127.14. And you do answer times x. You get 137.74. Do it again. And notice that all of mine are stored, so I can't make a mistake.
I got the answer.
149.21. Do it again.
Oh wait.
Answer times x. You get 161.65.
Oh, I see, right, yeah.
175.12.
This is really fun to do.
A few more of these to do. I'm trying to.
I finished off with 306.
Okay. I think that's
So
all we-
far, I've gotten every number you've gotten. 306.66. Well,
Well, you're wrong.
you're not done yet.
What do you mean? That was good.
How about one more time?
That's 13.
No, I didn't count my months wrong.
Yeah, you did.
Oh, I did. 1, 2, 3, 4, 6, 7, 8, 9, 10.
13.
God, you messed me up. I can't count.
13.
I'll make sure that I also did not miscount. I need to count.
Fine. 13.
First, 2, 3, 4, 5, 6, 7.
That's a lot of
9,
numbers.
10, 11, 12.
So it was 283.07. What? How'd you get to the
261.
hold up?
That was the number just before.
Hold up. Yeah.
Wait, Mr. Snell, are you sure you did that right? Because I think that's 11.
Let's go ahead. You guys can count with me.
Oh my
Calculator.
god.
Calculator, go away. Calculator, go away. My goodness. Why is it not? I just found this.
4 squared.
Okay, ready? Here we go. We're gonna count together. I don't know how much lag there is. Okay, you guys count with me.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How does that make mathematical sense?
No way.
Okay, 1, 2, 3, 4, 5, 6. I got 12.
I got 12 too.
What was your very first one?
Never mind. Yeah, I got it.
The first one you should have counted was 108.33.
Yeah.
That was my first one.
Yeah, I was looking at the ones I had put hands on. I didn't count the first one because it didn't have anything on it. So
Okay,
he's right.
Oh yeah.
you're all okay? Chloe, you're okay? That was tedious and we made mistakes. There's gotta be an easier way, right? Right, all right, because essentially what we're doing is we're doing this. Let me write it all the way out. We are doing this. We're doing 100 times 1.083. I'm gonna go ahead and round here, deal with it. Times 1.083 times 1.083 times 1.083, et cetera, et cetera, et cetera. Isn't that just repeated multiplication?
So
Isn't it a shortcut for repeated multiplication?
exponents, maybe?
Exactly. So it's 100 times 1.083. And then what was that 1.083? How many times do we do that? 12. Let's go ahead and see if that works, shall we?
Bet.
You guys do it on your calculator, see if it works. You get $261.30.
$260.34.
260.34.
Yeah.
Okay.
Oh,
That's because you.
you rounded again. You have to have that number exact.
Wait, what? What did I
Type in a bunch of threes and then it'll be better.
Oh,
Okay, so you're not putting the 12 outside of the
Okay, there we go.
parentheses, you're
Yes.
doing an exponent? Okay, because I was thinking that you put 12 outside of it because you're doing 100 times 1.083 12 times.
Nice. Okay.
But that gives you a bigger number than what the answer is.
Yeah, because I think you're multiplying, right?
Yeah, I put 100 in parentheses, 1.083, and then 12 outside of the parentheses.
Oh, so you're getting the 100 on the inside of parentheses.
No, like 100, like 100. Okay, and then in parentheses, 1.083. Outside of the parentheses, 12
As a multiplication or power?
as a multiplication.
I see that. So you're doing repeated addition. And that's, if you keep adding this number over and over again, that becomes gigantic really fast. Because, for example, 1 plus 1 is 2, which means you come from increasing by 8% to increase by 200%. Adding numbers that are representing percentages is really, really dangerous. Yeah, you have to constantly multiply them, and multiplying repeatedly shorthand is exponentially or not exponential, but taking it to an exponent. All right, so let me generalize. And eventually, I will get to this. This is the answer to today's lesson, which we haven't even got to yet. Let me generalize before I get there, though. So, generalization. We will get to example 5. It's just we're not ready for it yet. In general, this is how we'll calculate interest. You'll always do start. Can we change out the name for start? To the professional name?
Those professionally.
Professional is called the principal. AKA
Principal.
Principal. It's the same spelling as principal, Miss Sasson. It's not principal as in I have solid principles and I believe that stealing is wrong. That's PRINCPLE, so the ending is a little bit different. So it's gonna be your principal times, in parentheses, 1 plus, and here's technically all the math that we did. So in order to find this 1/12, we did we did 1 divided by 12, so we did the percent, I guess we'll say, percent divided by the number of periods that we had. So instead of say 12 down here, I'm gonna say 10. So this number right here was our 1.083. We took our percent, in this case 100%, and 100% as a decimal was 1. So we did 1 divided by 12, and then we took it to the power of 12. So and these are both going to be n in this case. So far, so good.
We hit this.
Okay, so there's a pretty logical question to ask, and I'll try to really point you guys in the right direction so you guys ask it yourselves. This is how much money we had if we compounded it only 1 time a year, compounded it 2 times a year, compounding it 4 times a year, compounding it 12 times a year. What question do you want to ask?
What if we compound it 24 times?
Go think bigger. Bigger.
48 times?
Bigger.
62 times?
Bigger. Mathematically as
60.
big as possible.
Mathematically.
What is the biggest number that you would say
1 trillion.
even bigger?
Oh wait, isn't that where,
Infinity.
There it is.
Oh.
What if you did this infinitely? Not even second by second, not even millisecond by millisecond. Millisecond would have like a bunch of bumps right here, right? What if we did it infinitely? Which there's a word for that, it's called continuously. What if we really just max it out, plug in infinity and see what happens? Let's check it out. That's question 5. What happens if I do my $100? My $100, and I do that, and I'll write in here continuously. And we're going to use our general formula to do that. So we're moving to infinity. If we do it continuously, we're going to have our start in this case was $100. And we're going to multiply in here by 1 plus our percentage. We're increasing by 100%. Thank you, Jeffrey. Thank you, Jeffrey.
Jimmy.
wow.
Thank you, Jimmy B. Thank you, Jimmy B, for the 100%, which we'll convert into a decimal in a second. And then we're going to do the divide that by infinity. I'll show you. And we're going to take that to the power of infinity. The problem is we can't plug in infinity. You have to take limits, which again, you usually take calculus. Once you take AP calculus, then you're like, okay, you don't really plug in infinity, but there's a few little math tricks that you can do. Let me show you what happens in general. There's going to be 2 things that I don't know. How do I do that, and how do I do that? Right? Let's first do this one. What happens if I do first? What is 100% as a decimal? 1. So this is really going to turn into 1 divided by infinity. Let's go ahead and just check. What's 1 divided by 10? What's 1 divided? You guys on your calculators do this as fast as you can. 1 divided by 100. 1 divided by a big number. 1 divided by like the biggest number that you can enter into your calculator, and this will eventually turns into. Just keep adding zeros on that bottom. What does it eventually turn into?
1 times 10.
Oh, it turns into 100.
What?
No,
Oops, all the way back.
if I just keep on typing 100.
What is 1 divided by 1 with a bunch of zeros on the bottom?
Oh, I thought you meant in the formula.
Oh, not in the
How
formula.
long can I keep doing this?
Negatives. Oh.
Oh, the
I'm going up
times
to
10 to the negative 15, like 1 times 10.
Oh, it won't round. That's interesting. So it's fun to do it on these calculators because they eventually give up.
Oh.
Eventually, when they give up, they'll eventually say, you know what? It's 1 times 10 to the negative 1,000. And you know what? By that point, you're basically at 0. It's such a small number. This gets really, really close to 0.
Just it won't give up. I think that I'm gonna break. Yeah, I got to like that. I was going up all the way to 1 times 10 to the negative 2 power.
200.
So the problem with doing it this way, I'm realizing that this won't work and it's making me feel really silly, is when I take this to the power of infinity, these are competing forces. When I take things to bigger powers, for example, if I take a number like 1.5, take 1.5 to the power of 1 and then keep adding zeros in here and see what happens.
Undefined.
It eventually gets so big that it turns into infinity, which the calculator interprets as undefined. You have these two forces that are gonna balance out at a weird spot. One of the forces is saying get bigger. The other force is saying get smaller. So which one wins? And
Okay.
here's how we're gonna solve this, with a table.
What?
Watch this, hold on, that's not the. Are we out of here? Rush.
Yep, you're out of here in a couple seconds.
I'm gonna go ahead and make a table, and I'm gonna make a number that I can enter in as big as possible. Like this, I'm gonna type in the formula over here. We'll just finish this tomorrow. The answer is gonna be a table. The table is going to make something really, really interesting happen, but we will finish that again tomorrow. So try to
So
remind me.
then you can graph,
Bye.
and actually make a table by all the.
Bye, Alden.
Hey, my wife says bye.
Oh, wait.
She said bye
Oh,
first. That's why I said bye. I heard her.
Chloe didn't say bye.
Oh.
Didn't
I
say
didn't
bye
hear
bye.
her say bye. I thought you just said bye and then she left. I'm like, okay.
That's messed